Hello guys, welcome to Spark Tech Academy. Now today we will be going through some problems of voltage extension range and current extension range. In that I will solve the questions. First question will be on voltmeter extension range. Just now we have covered the lecture regarding voltage extension range, means voltmeter extension range. Now what is given? The full scale deflection current, which is IFSD, is given as 10 milliampere. Now the voltmeter V scale is given as 50 volt, and internal meter resistance Rm is given as 100 ohm. Now as far as such kind of problem comes into picture, because it is nothing but a word problem statement, from that these things you have to first note down, means you have to mark it down, and accordingly now while solving this equation, first of all write the voltmeter extension formula. Now in this case what is given is the 50 volt is being given. This is nothing but the V from this equation. Now we have to calculate Vm. In previous lecture actually we have solved this. Vm is nothing but Im into Rm. Now Im is nothing but IFSD. You can also write IFSD into Rm. Now 10 into 10 raised to minus 3 into 100. It is nothing but 1000 into 10 raised to minus 3. It is nothing but 1 volt. Now what we will do is we will calculate the M. M is nothing but the multiplier which is used for the series extension. Voltage is given as 50 and Vm is given as 1 volt. It is nothing but the value of Vm will come out to be 50. It is unitless as it is just the multiplier. Now we have to calculate the RAC. RAC is nothing but we have Rm 100 ohm into M minus 1, it is not 1 minus M, 50 minus 1, hence 4900 ohm. You can write it as 4.9 kilo ohm. Very simple, as simple it is. Just you follow the steps what I have told you. Just take down the given data and first clear the idea while writing the given data or assuming the given data. Just try to interpret the data and accordingly you just implement the formula. What is V, what is Vm, how to calculate the Vm is nothing but Im into Rm. You can also say as IFSD into Rm, full scale deflection current into Rm, and accordingly you will calculate this, and just I have substituted the values. The answer will be matching your MCQ. Now the next problem will be on sensitivity. In case of sensitivity, the question 2, what is given? The sensitivity is given sensitivity is given as 1000 ohm per volt and full scale deflection voltage is given VFSD. It is nothing but 100 volts. Now they have told us to calculate the internal resistance of meter, means RM we have to calculate. You know one thing, sensitivity formula already we have gone in previous lecture. Sensitivity is nothing but 1 upon I into full scale deflection. 1 upon full scale deflection. Now accordingly IFSD will be nothing but 1 upon 1000. Just substituting the rearranging the equation and substituting the value of sensitivity here, you will get it as 10 raised to minus 3 milliamperes, or you can say it will 10 raised to minus 3 amperes, means 1 milliampere. Now you know what is RM. RM is nothing but VFSD divided by IFSD. Now VFSD is given as 100 volts divided by current 1 into 10 raised to minus 3. You will get as you will get as 100 kilo ohm. This is nothing but the RM. Just now we have found out. Please note it down. This is also a little bit typical problem. It will be asked in your exam. Now again one problem I will be taking. In that case, question number 3, you can say V, Vm both are given. V is given as 60 600 and this is 60 millivolts. IFSD is given. Im equal to IFSD equal to 6 milliampere. For sake of simplicity I am writing this. Now you know what is RM. RM is nothing but Vm by Im. So you just calculate it. Vm is 60 into 10 raised to minus 3 divided by 6 into 10 raised to minus 3. It will get cancelled. It is nothing but 10 ohm. Now what they have told you, they have asked the RSC. You know the RSC formula. RSC formula is nothing but Rm into m minus 1. Rm, just you have to, again one thing, you have to calculate m. M is nothing but V by Vm. In this case both are given, so please note it down accordingly. This will be, its value will be 10. Now just resubstitute the values. 10 into 10 minus 1 RSC is equal to 90 ohms. This is your answer. Just follow the steps, you will get the answer. Please note it down. Now again one problem of multiplier shunt. Multiplier shunt is nothing but ammeter extension range. Ammeter extension range problem. this case, what they have given is, they have given Vm as 50 millivolt. They have given Im as 10 milliamperes. They have given the range of I as 5 ampere. Now, what they have told you to calculate? They have told you to calculate RSH. You know what is RSH formula? It will be Rm divided by m minus 1, and here m will be I divided by Im. First try to calculate this. 5 divided by 10 into 10 raised to minus 3. In this case, it will be 0.5 into 10 raised to 3. The value will be 500. And accordingly, Rm, you know Rm is nothing but Vm by Im. Just substitute the given values. 50 divided by 10 is nothing but 5 ohm. Now just substitute the values in this equation. You will get 5 divided by 499, and its answer will come about 0.01 ohm. This is nothing but the final R shunt answer. So please note it down. It is very helpful and it will be definitely asked in exam. Ammeter extension range. In many competitive exams, this has been asked. Now again one problem I will be taking of PMMC instrument. This is also asked many times in exam. In PMMC instrument problem, they have given flux density B as 5 Weber per meter square. They have given N is nothing but number of turns as 200. They have given controlling torque TC is equal to 360 into 10 raised to minus 6, and length, they have given length as 8 and width as 6 mm. Now from this you have to calculate the I, the current through the coil. Now what you will do is, you will just write the equation. TD is BINA. Already we have derived this. In this case, flux density is being given as 5 into I is unknown here, 200 tons already given, and area, and this is TD. Now calculate the area. Area is nothing but length into width. It is given as 8 into 6 is nothing but 48 mm square. Now convert into meter square. That's why we have just converted it to meter square, 10 raised to minus 6. TC is already given. TC is given as 360 into 10 raised to minus 6 Newton meters, or you can say kg meters. Now you know for steady state situation, TC is equal to TD. Hence just try to evaluate this. TC is 360 into 10 raised to minus 6 is equal to TD is 5 into I into 200 into 48 into 10 raised to minus 6. Just I have substituted the values in this equation. Now what will happen is, in order to calculate I will be nothing but 360 into 10 raised to minus 6 divided by 5 into 200 into 48 into 10 raised to minus 6. In this case, this 10 raised to minus 6 will get cancelled, and accordingly what happens is, just solve this, you will get the answer as 7.5 milliamperes. This is nothing but the answer. This is in case of PMMC instrument. The TD, deflecting torque, TC is nothing but controlling torque. Both are equated at steady state, and accordingly we have just calculated the answer. As per your options, this is the matching 7.5 milliamperes. So note it down. Thank you for watching eSpark Tech Academy. Just now we have solved a few examples on ammeter extension range, voltmeter extension range, PMMC, sensitivity. These are very must coming problems, or these are very important problems as per competitive exams. Thank you for watching eSpark Tech Academy. Please do like and subscribe the channel. It will motivate me to upload more and more example related lectures. Thank you.